Before we plunge into the statement, it's critical to comprehend the significance of what we are examining. The enormous Hadron Collider, LHC, overseen by CERN, represents a great leap forward in the field of science. Extending across 17 miles, this multifaceted organization of superconducting magnets is not only the largest, but also the most powerful atom smasher ever built. It stands as a testament to human creativity and the remarkable achievements we've made in the domain of scientific understanding. Surprisingly, the LHC is so powerful that it can reproduce conditions similar to those that existed at the birth of the universe. Yet, as we venture into the vast field of the cosmos, we must ask, could this machine, which seeks to uncover the deepest mysteries of existence, also expose us to unforeseen risks? Established in 1954, CERN is one of the most respected scientific research organizations in the world. With 23 member countries and an extensive network of experts, it serves as a central hub for collaboration and groundbreaking discoveries. While the LHC is its flagship project, it is just one part of a wide range of particle accelerators and experiments. Think of it as a track, not for cars or horses, but for subatomic particles racing against each other in a high-stakes test of speed, precision, and the fundamental nature of reality. Inside the LHC, protons are accelerated to speeds approaching that of light, replicating the energy levels present at the moment of the Big Bang. The resulting collisions generate temperatures far exceeding those at the core of the Sun. A series of magnets guide the protons along their paths, while complex cooling systems maintain temperatures lower than those in space. These collisions are deliberately set to occur at 4 separate locations around the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, record data. Each detector plays a unique role, offering distinct perspectives on the aftermath of these high-energy crashes. Together, they function as enormous cameras, capturing the resulting debris as scientists meticulously sift through the data to identify elusive particles such as the Higgs boson, often called the God particle, and other phenomena that could shed light on the fundamental building blocks of the universe. By focusing on the subatomic level, researchers hope to gain insight into the very fabric of the cosmos. However, every discovery made at the LHC raises even more questions. The LHC is more than just a scientific instrument. It represents humanity's relentless curiosity and quest for knowledge. It reflects our drive to understand the forces that govern our reality. Yet, as we push the boundaries of the unknown, we must also confront the ethical and existential dilemmas that come with it. What risks might arise from probing too deeply into the unknown? Could our pursuit of knowledge unleash forces beyond our control? At CERN, where the limits of human understanding are pushed to their extremes, a disturbing realization has emerged, one that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former CERN scientist and a highly respected figure in particle physics, recently made a startling statement that has both fascinated and unsettled people worldwide. Cox revealed that the LHC's purpose is to recreate a miniature Big Bang. Yes, a small-scale version of the very event that created our universe. Cox went on to explain the immense potential of the LHC to uncover groundbreaking discoveries, such as solving the mysteries surrounding dark matter, a substance that comprises a vast portion of the universe. The possibility of harnessing the fundamental forces of the universe is undoubtedly captivating. However, it also comes with its own set of risks. The mini-Big Bang is not just a theoretical concept. It is a real phenomenon occurring within the LHC. The collider replicates conditions of extreme heat, pressure, and energy, mirroring the environment at the dawn of the universe. It is as if we are witnessing the birth of time itself. However, with such immense power comes great responsibility. What if something goes wrong? This concern is not new. In 1978, Russian physicist Anatoly Bugorsky experienced an incident that drastically altered his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused a proton beam to accidentally cross his path. The beam, traveling at an incredible speed, pierced his skull. Entering from the back, and exiting through his nose. Vygotsky saw a flash of light brighter than 1,000 suns. He remained conscious and walked to seek medical attention. The aftermath was both fascinating and alarming. He lost hearing in one ear and suffered partial facial paralysis. Despite the severity of the injury, his cognitive abilities remained intact, and he continued his scientific work. Vygotsky's experience serves as a grim reminder of the power and potential dangers of particle accelerators. The risks associated with a particle collider like the LHC should never be taken lightly. Concerns about unforeseen reactions that could alter the very fabric of reality have led some scientists to worry about the possibility of creating a miniature black hole within the collider. Black holes are regions of space where gravity is so intense that not even light can escape. These destructive forces lurk at the edges of the universe, and the idea that the LHC could create even a tiny black hole is both awe-inspiring and terrifying. Could such a black hole grow uncontrollably, eventually consuming the Earth from the inside out? CERN scientists have reassured the public that any black hole created would be highly unstable and would evaporate almost instantly. Still, the remote possibility of such an event has sparked widespread debate and concern. To understand how the LHC could potentially create a black hole, we must first examine the fundamental operations of a particle collider. When protons collide at nearly the speed of light, the energy generated is so immense that it can warp the very fabric of space-time itself. Imagine a tightly stretched trampoline with a heavy object dropped onto it. The fabric bends, and if the object is massive enough, it can create a depression so deep that anything nearby would be pulled into it. This analogy offers a glimpse into how the LHC might affect space-time at a quantum level, where the laws of physics become strange and unpredictable. A theory has been proposed suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and one of time. If these extra dimensions exist, the LHC could potentially tap into them, creating a gravitational well that forms a microscopic black hole. The possibility of this happening has drawn the attention of renowned physicists, including the late Stephen Hawking. In his works, Hawking warned about the Higgs boson becoming unstable at extreme energies, potentially triggering catastrophic consequences like vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised concerns about the LHC's experiments. In his book on the future of humanity, he explored the potential dangers posed by particle accelerators, acknowledging that while the chances of such an event were low, even a small probability warranted careful consideration. The stakes are high, and the margin for error is razor-thin. Researchers at CERN have conducted extensive simulations and analyses, taking every precaution to ensure. If the LHC is indeed capable of accessing these hidden dimensions, the implications are profound. Could we inadvertently open a passage to another reality? Might we encounter unknown phenomena, energies, or even forms of matter that challenge our current understanding of physics? These questions, while often dismissed as speculative science fiction, touch upon real concerns within the scientific community. Theoretical models suggest that if extra dimensions exist, the LHC's high-energy collisions could momentarily reveal them, offering glimpses into an unseen aspect of the universe. Yet, with these possibilities come uncertainties. Some physicists speculate that such an event could trigger unforeseen consequences, altering the very fabric of our universe in ways we cannot yet predict. Could such experiments destabilize space-time? Might they influence cosmic structures on a fundamental level? Despite these concerns, CERN researchers assure the world that the LHC operates within safe parameters. They emphasize that nature itself conducts similar high-energy experiments daily. Cosmic rays, far more powerful than anything produced at CERN, constantly collide with Earth's atmosphere, producing energetic particles without catastrophic effects. Still, not all skeptics are convinced. Throughout history, technological advancements have occasionally outpaced our ability to fully grasp their risks. The development of nuclear weapons, artificial intelligence, and genetic engineering all serve as reminders that scientific progress carries both promise and peril. As we continue probing the fundamental forces of the universe, we must ask, Are we prepared for whatever we might discover? And more importantly, do we fully understand the consequences of unlocking the secrets of existence? The LHC is not just a machine. It is a gateway to the unknown. Whether it leads to new frontiers of knowledge or unforeseen dangers remains one of the most pressing questions of modern science. Perhaps the answers lie just beyond our current reach, waiting to be uncovered in the next great collision at the heart of CERN. Energies never before seen on Earth could make waves that test these covered-up aspects. While this remains speculative, it shows the appeal of the obscure and the chance of finding different aspects, which continues to intrigue the public. Despite the fact that mainstream researchers have doubts that the LHC will create a gateway to another universe or even to damnation itself, the idea of the LHC as a grand key to unlocking new realities continues to captivate many. So, should we be concerned about the dangers implied by the LHC? It's easy to get caught up in exciting headlines and fears of cosmic disasters. The reality, however, is that scientists at CERN are fully aware of the potential risks. They have taken every precaution to ensure the safety of their experiments and continuously monitor and evaluate their work with the highest level of diligence. The potential benefits of their research, such as uncovering the mysteries of dark matter, discovering new particles, and expanding our understanding of the universe, are truly remarkable. These breakthroughs represent a significant leap forward in human knowledge, yet they come with inherent risks. Like all great scientific advances, the LHC's experiments raise profound ethical questions. Could the creation of exotic particles or the exploration of extreme energy conditions trigger unforeseen consequences for our planet, or even for the very fabric of reality? These are questions that cannot be taken lightly and must be carefully considered within the broader implications of scientific progress. In conclusion, the Large Hadron Collider is a great achievement in human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the fundamental workings of the universe. However, as we explore these mysterious frontiers, we must remain cautious and mindful of the potential risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, yet it is not without its challenges. The LHC stands at the forefront of scientific exploration, where theory meets experimentation and where the foundations of our understanding of the universe are being tested. The journey of discovery is never without risk, and the LHC is no exception. It pushes the boundaries of physics, striving to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. Yet, as we continue to explore these frontiers, we must also consider the profound moral and existential dilemmas that arise from manipulating the forces that govern the universe. The potential risks of unforeseen consequences, whether for our planet or for the very fabric of space-time itself, remain a challenge that demands thoughtful reflection. Nevertheless, the pursuit of knowledge remains one of humanity's most noble endeavors. The LHC's experiments, though risky, offer us a glimpse into vast, uncharted realms of science. As we stand on the brink of discovery, we must approach this journey with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement, but also a powerful tool that has the potential to reshape our understanding of everything, from subatomic particles to the most grand cosmic phenomena. With every breakthrough comes a new wave of questions, opening new avenues of exploration and thought. The path of scientific discovery is uncertain, yet it holds the promise of revelations that could redefine our understanding of the universe, our place in it, and the very laws that govern reality. One of the most profound aspects of the LHC's experiments is the intersection between theory and reality. For centuries, physicists have struggled to understand the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single cohesive framework, a theory of everything. The LHC has played a crucial role in providing both experimental evidence and insights that bring us closer to this elusive goal. Its work not only advances our understanding of particle physics, but also holds the key to unlocking the fundamental truths of existence itself. The ethical dilemmas associated with these experiments are significant, yet the pursuit of knowledge has always been fraught with risk. When those risks involve altering the very fabric of space-time, however, the stakes become even higher. Could a single experiment at the LHC unintentionally trigger a phenomenon we do not yet understand, leading to consequences that are impossible to predict? This is a question that scientists, philosophers, and ethicists continue to explore. As we venture into these mysterious realms, we must remain mindful of the responsibility that comes with wielding such immense power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical breakthroughs, and a deeper understanding of the universe are immense. The discoveries made by the LHC so far have already transformed the landscape of science. From the identification of the Higgs boson to advances in our understanding of dark matter, these achievements have far-reaching implications, not just for physics, but for other fields that rely on this foundational knowledge. As we continue to push the boundaries of possibility, the LHC serves as a reminder that science is never without uncertainty. No experiment is entirely without risk, and the LHC, as grand and powerful as it is no exception. But with every risk comes the potential for extraordinary discoveries. The LHC is a symbol of humanity's relentless pursuit of knowledge, a quest to answer the questions that have puzzled us for centuries. Ultimately, it is this curiosity that drives us forward, the desire to understand the universe, to peer into the depths of space-time, and to uncover the forces that govern everything from the smallest particles to the largest galaxies. Scientific progress is a double-edged sword. The LHC may carry risks, but it also represents the pinnacle of human achievement in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to mysteries that have eluded us for centuries. Whether the LHC leads to the discovery of new dimensions, opens doors to parallel universes, or triggers unforeseen phenomena remains uncertain. What we do know is that it is one of the most powerful scientific instruments ever created, capable of revealing secrets about the universe that were once thought to be beyond our reach. The potential for discovery is boundless. As we delve deeper into the unknown, we are reminded that science is a journey, one that requires both boldness and responsibility. The experiments at CERN continue, and we must remain aware of the possibilities, the risks, and the vast potential for new understanding that lies ahead. The LHC, while embodying the cutting edge of modern science, is also a reflection of our deeper quest for meaning and understanding in a vast and mysterious universe. Every new discovery brings us closer to a fuller comprehension of the forces that shape our reality.